In this lecture, you will learn the unit we prefer to use in math to describe the measure of an angle, the radian. After going over the definition of a radian, you will learn to measure the most common angles in the plane in radians. The skills you need to master this lesson are an elementary understanding of mathematics. Let's quickly recall some geometrical terminology about angles and circles. Given an angle and a circle, if the vertex of the angle is at the center of the circle, the angle is called a central angle. For example, here we have a circle with center O, and we have an angle AOB whose vertex is also O. Therefore, this angle is called a central angle. If you put the vertex somewhere else, for example, if the vertex is on the circle, then this angle is not a central angle. All right, that's the first terminology I wanted to remind you of. The second one is that of an intercepted arc. In this circle here, we say that the angle AOB intercepts the arc AB. The arc is a portion of a circle. The portion of the circle that is inside the angle is called the intercepted arc. That's a second piece of terminology I wanted to remind you. Before we go over the defining statement of a radian angle, let's say simply what the radian measure indicates. So given a circle and a central angle, here's a circle, and let's take a central angle. This is the center of the circle. Central angle will be this angle right here at the center of the circle. The radian measure of the central angle. So I want to measure this angle, but now I want to measure it in radian. Let me call this measure x. So the radian measure of this angle indicates how many radii there are on the intercepted arc. So let's take a radius. Let's take this segment as the radius of the circle right here. The radian measure is telling you how many radii you can put on the intercepted arc right here. So basically, the radian measure answers the question, how many radii on arc AB, let's call A and B, these 2 points right here, how many radii on arc AB? The answer to the question is x, the measure of the angle in radian. Sometimes we would write x rad, but usually we omit the unit because x is just a number, the number of radii on the intercepted arc. Let's try to understand that a little bit more. So suppose I'm giving you a circle with one of its radii right here, and suppose I have an angle that intercepts an arc, and on this arc I can put exactly one radius. Okay, so the length of the arc is the same as the length of the radius of the circle. Then the measure of the angle right here, if I call that x, I'd have x equals 1, or 1 radian, 1 rad. Why? Because there is one radius on the intercepted arc. The length of the intercepted arc is the same as the length of the radius of the circle. Okay, let's go over another example. Okay, so here's a circle again with one of its radii. Length of the radius is r. Let's take another angle, let's say this one right here. And now suppose that the intercepted arc contains exactly 2 radii. Maybe one is going to be right here. This length is r, and then another one right here, another length of r right here. What is the measure of the angle in radian? Well, how many radii did you put on the circle? 2. So the measure of the angle in radian is 2, or 2 rad. Again, I usually don't write the units because an angle in radian is just a number. The number of radii you can place on the intercepted arc. Let's go over another example. All right, so same circle, same radius. Suppose now that here's R, here's another, and let me go maybe one more right here, okay? And I'm wondering, what is the measure of this angle in radian right here? Well, how many radii did I put on the intercepted arc? 1, 2, 3, 4. So x equals 4. It is very, very simple to understand the measure of an angle in radian. One more example before we generalize a little bit. So again, same circle, same radius. Suppose this arc has a length of r. Suppose this one has a length of r right here. And now I want this arc right here. We're going to assume that this arc has the same length as that arc. So what is the measure of this angle right here? Well, how many radii did you put on the intercepted arc? There is one right here, right? And right here, there is half of one. So x is just 1.5 because there is 1.5 radius on the intercepted arc. You see, it's really straightforward, right? Okay, let's try to generalize that. So suppose now that you have the same circle with the same radius r right here, and suppose that we are looking at an intercepted arc that measures, let's say, S. Okay, that's an arc. And this is the angle that intercepts this arc. Now, to measure S, we use the same unit as we use to measure R. If R is measured in centimeters, S is measured in centimeters. If S is measured in inches, R is measured in inches. S represents this length right here. Okay? Now the question is, what is the measure of the angle x that intercept the arc of length s? The measure in radian, of course. Well, this question is equivalent to how many are in S? How many radii I can put right here? 1, 2, okay, and I'm not sure how many. I need to count, right? How many are in S? How do we count the number of R inside S? How do you count the number of 4 inside 21? Well, you do 21 divided by 4. It is not going to be an integer, but it's going to tell you how many are inside S, how many 4 inside 21, right? So if you want to know the measure of x, you need to count the number of r inside S. And this number is S divided by r. And that number will be the measure of the angle x in radian. Let's now go over the definition of a radian. Here it is. In a circle, 1 radian is the measure of a central angle that intercepts an arc whose length is the same as that of the radius of the circle. If the circle has a radius of length r, then the length of the intercepted arc is also r. And this definition can be illustrated as follows. Here we go. So you take a circle with radius OA. Let's say the length of the radius is r right here. And you rotate this radius OA around the point A. So all these segments right here have a length of r. All right, you rotate the segment. Right now they're all straight. So all these segments right here are straight until you hit the circle, let's say here. Okay, that's the last straight segment. The length of the segment is r. Once you here, then you push the segment against the circle very, very tightly. You push the segment against the circle. So you see this point right here is going to drop a little bit because I'm pushing, right? And then you're going to get right here an arc whose length is exactly the same as that of the circle. Well, then the measure of this angle in radian is, if you call that x, it is 1 or 1 radian. Okay? All right. Let's go over the property that we have already mentioned. Here's a property. It comes directly from the definition of a radian, and we understand why we have it. We already went over it. If you take a circle, and if you take a central angle that intercepts an arc of length, let's say this length right here is S, and the radius of the circle is R, then the measure of this angle right here, x in radian, is the length of the arc divided by the length of the radius. And that's the number of radii on the arc. How many r can you place on the arc right here? Again, this number doesn't have to be a natural number, okay? Now, it is common not to use x to represent an angle in radian. We usually use letters from the Greek alphabet. In this property, I've used the letter theta. So theta equals s over r. And also, I'm going to say this is normally not the way we remember the formula, although it's completely fine, but we multiply both sides by r, and so we have the formula S equals r times theta. That's a formula we normally remember. This is the length of the arc, the length of the intercepted arc. This is the radius of the circle, meaning the length of the radius of the circle, and this is the angle. It's the angle measured in radian. It's very important. This property is only true when you use an angle in radian. Okay, so make sure you know this property. It is fundamental to understand what a radian is. All right, let's practice it. So what do we have in the first example? A circle of radius 8 inches. So here's a circle. Let's say the radius is 8 inches. So here we go, 8 inches. Okay. And a central angle, so let's draw a central angle. It doesn't matter where I draw it. Intercept an arc of length 24 inches. So right here, the length of the arc, is what I call S, is 24 inches. 8 is R. Okay, what is the measure of the angle in radian? So let's call this measure theta. What is the measure of theta? How many 8 in 24? Well, that's pretty simple, right? Theta is S divided by R, or it is 24 divided by 8. So theta is 3. You can write 3 rad, but we don't need to put the word rad. We know what it means when I don't add a unit. It means 3 radian. If I were to talk about another unit, like if I were to talk about degree, I have to have the degree sign, but this is not degree right here, okay? So theta is 3. Next example. So here again, I'm given a circle. This time the radius is 2.5 centimeters. All right, so the circle and the radius is 2.5. And a central angle of measure 4. So this time I am given a central angle right here, theta, and I know that theta equals 4. What is the length of the arc? I want the length of this arc right here. So there's two ways to do that, right? Either you understand what 4 means. 4 means that you can put 4 radii across the arc. I shouldn't say across, on the arc. 1, 2, 3, and 4. So 4 times 2.5 is just 10. Or you just use a formula, S equals R theta. R is 2.5. Theta is 4. 4 times 2.5 is 10. 10 what? 10 centimeters. So the length of the arc is 10 centimeters. Again, this formula is fundamental. It's only used when theta is given in radian. That was the case right here. The central angle measure 4 radian. Next example. So we have another circle. This time the radius is 1.5 meters. So here we go, 1.5 meters. And the central angle intercepts an arc of length 90 centimeters. The length of the arc is 90 centimeters. Okay, so here I have a little issue. I hope you can all see that right away. One is given in centimeter and the other one is given in meters. We have to be very careful right here. So 90 centimeters is 0.9 meter, all right? And the question is, what is the measure of the angle? So you have to be very careful to convert your unit, okay? So theta is S divided by R. S is 0.9, R is 1.5. So on your calculator, when you do 0.9 divided by 1.5, you will find 0.06. So the angle measures 0.06 radian. All right, in this example, I have a circle of radius 2.5 centimeters. So the circle has a radius of 2.5 centimeters right here. and a central angle of measure 4 pi over 5 intercept an arc. So I have a central angle that measures 4 pi over 5. So theta is 4 pi over 5. It is a central angle and it intercepts this arc right here, S. What is the length of the arc? So start with the formula if you want. S equals R times theta. You know R is 2.5, and you know theta is 4 pi over 5, okay? So what is 2.5 times 4 pi over 5? Well, 2.5 is 5 over 2 times 4 pi over 5. So you simplify you 5 by 5, 1. 4 by 2, 2, 2 by 2, 1. And so it is 2 pi. So right here, this arc length is 2 pi. 2 pi what? 2 pi centimeters. So this length right here is 2 pi centimeters. Okay, let's go now over the next set of examples. In this set of examples, I want to write the measure in radian of all the common angle in the plane. Let's see how we do that. All right, here's the first question. What is the circumference of a circle of radius r? Well, that's a very old formula, 2 pi times r. Then, what is the measure in radian of a central angle that intercepts the circumference of the circle? Okay, let's try to understand that. So, I have a circle, I have a central angle, and the intercepted arc this time is the circumference, the whole circumference. My angle, it doesn't intercept just part of it, it intercepts the entire circumference of the circle. So the terminal side of the angle is at the initial side right here, right? So here's the angle theta that I'm looking for. The radius of the circle, let's call that r. And the arc, S, well, this time it is the whole circumference. So it is 2 pi r, right? Okay. What is the measure of theta? Well, what's the formula between theta, r, and S? The formula is S equals r times theta. S, we said, is the whole circumference of the circle. So it's 2 pi r equals r times theta. And now, if you divide both sides by r, what do you have? You have theta equals 2 pi. Now that is very important and you need to remember it. The angle that intercepts an entire circle has a measure of 2 pi. Another way of saying that is 1 revolution corresponds to 2 pi, or if you want, 2 pi radian. Okay, so, and 2 pi correspond to 360 degrees, right? So again, 1 full revolution corresponds to an angle of measure 2 pi. Let's remember that. So what does that radian correspond to in degrees? So 2 pi corresponds to 360 degree. Again, this is 1 full revolution. 2 pi or 360 degrees or 1 revolution. All of these are fine units to measure angles, okay? Next question. What is the measure in radian of a central angle that intercepts half of the circumference of a circle? So this time, you have a circle, and you want to find the measure of a central angle that intercepts half the circumference. So this part right here, right? Well, what do we call this angle? This is called a straight angle, right? So basically, I'm asking you, what is the radian measure of a straight angle? Well, if to go around, you need to turn 2 pi radian, when you go halfway around, you turn pi radian. 2 pi divided by 2 equals pi, okay? So pi radian, again, I usually don't write rad, correspond to a straight angle, is a measure of a straight angle in radian. And what does it correspond to in degree? Pi corresponds to 180 degree. Make sure you always indicate degree. You do not have to indicate the unit in radian. Next measure. Okay, so now I want to intercept 1/4 of the circumference of a circle. That means 1/4 of a revolution. That means a right angle. So the question right here is, what is the measure in radian of a right angle? Well, what's the measure of a straight angle? We just went over it. It's pi, right? So if you divide a straight angle in two, you will find the right angle. So the measure of a right angle in radian is pi divided by 2. What does it correspond to in degree? Pi divided by 2 corresponds to 90 degree. All right, next question. So this time I'm asking you what's a measure of the angle that intercepts 3/4 of the circumference? Well, that's pretty simple, right? We just said that the measure of a right angle is pi over 2. So 3/4 of the circumference is 3 right angle, right? If you take 3 right angle, you'll be 3/4 around the circle. So 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2. Here we go. This angle right here, initial side, terminal side, this angle has a measure of 3 pi over 2. Again, in degree, it corresponds to 270 degree. Now, guys, it is going to be very important that you stop doing this correspondence with degrees. But right now, it is so new that I'm going to keep on doing it, right? But you must be able to talk in radian all the way without translating to degree, okay? Next question. All right, so now we want to find the measure of the angle that intercepts 1/6 of half a circle. Now, you remember we've done that with degrees. How do you do that? So here we go. You go like this. You cut these segments in half like so, and then you draw these parallel line to the axis right here, right here, right here, and right here. Now, I am not going to draw the diagonal because I just want the 1/6. So here we go. 1, 2, 3, 4, 5, 6. That's how you divide a straight angle in 6 angles like that. And then 1, 2, 3, 4, 5, and 6. So, all right. I didn't do a very good job at it, but it's fine. It's okay. So, what is the measure of 1/6 of a half circle? Well, here's a half, right? And I divided a half in 6. So what's the measure of a half circle in radian? It is pi radian. So 1/6 of it, well, there's no other way to write it as pi over 6. That's it, okay? Pi over 6. And then you can do with that what we did with degree measure. You can count in pi over 6. That's 1 pi over 6 right here. This one is 2 pi over 6. 2 pi over 6 means pi over 3, right? 3 pi over 6, well, we already mentioned this one. That's a right angle. If you divide by 3 both sides, you're going to find pi over 2. 4 pi over 6. 4 pi over 6 is 2 pi over 3. 5 pi over 6, you cannot simplify it. And then 6 pi over 6, we know this one. This is pi, okay? So you can count in pi over 6. You can keep on going. 7, 8, 9, 10, 11, 12. 12 pi over 6, of course, is 2 pi. You simplify by 6 and you find 2 pi. 2 pi is 1 full revolution, okay? Anyway, to answer this question, it was just pi over 6, and that corresponds to 30 degree, okay? 30 degree. Next question. Okay, the next one is 1/4 of a half circle. So 1/4 of a half circle, what is that? All right, half circle is pi right here. Half of a half circle is pi over 2. 1/4, so I got to divide this in 2 again, right? 1/4, here's 1, 2, 3, 4. I divided a half circle in 4, right? So 1/4, pi over 2 divided by 2, or just pi divided by 4. Here it is, pi over 4. So this is 1 pi over 4, 2 pi over 4, 2 pi over 4 is just pi over 2. Makes sense, it's right here. 3 pi over 4, you can't simplify that. 3 pi over 4. And 4 pi over 4, well, that's just pi, okay? All right. So finally, let's report all of these measures on the circle with the usual angles. Here we go. All right, you recognize that. In degree, I'm going to put them here. We had a 30 here. We had a 45. We had a 60. That was 90. This one, 90 and 30 was 120. 90 and 45 was 135. This was 150, 180. I'm going to stop right here for degree. Check out your notes. They're all written in degree. But I am not interested in degree. I want radian. Okay, so we start with 0 radian, and then one full revolution was 2 pi radian. We started with that. Okay, so if one full revolution is 2 pi radian, half a revolution is pi, 2 pi divided by 2 pi radian. And then if you divide this in 2 again, pi divided by 2 is, well, just pi divided by 2, okay? So pi divided by 2 corresponds to 90. And then if you divide pi in 6, so now I'm talking about this one, this one, this one, and this one right here, right? So this is pi divided by 6. 2 pi over 6 is pi over 3, right? 2 pi divided by 6 is pi over 3. You simplify by 2. 3 pi over 6 is pi over 2. 4 pi over 6, 2 pi over 3. 5 pi over 6. 6 pi over 6, that's easy, that's pi. 7 pi over 6, I cannot simplify it. This one right here is not a pi over 6, right? It's a 45. It's a quarter of a straight angle. This is 8 pi over 6, that's 4 pi over 3, right? 8 pi divided by 6. If you divide by 2 both sides, that's 4 pi over 3. 8 pi over 6. 9 pi over 6. Okay, what is 9 pi over 6? 9 pi over 6 divided by 3 both sides. 3 pi over 6 by 3, 2. 3 pi over 2. We had come up with this one by counting the right angle. 1 right angle, 2 right angle, 3 right angle. 1 right angle is pi over 2, so 3 right angle is 3 pi over 2. Okay, so that was 9 pi over 6. This one is 10 pi over 6. 10 pi over 6, if you divide by 2, that's 5 pi over 3. So this is 5 pi over 3. And finally, 11 pi over 6. 11 pi over 6 does not simplify. All right, let me erase the work I've done for all of these angles right here. Okay, now what's left? What's left is the multiple of pi over 4, or 45. So this is the other family. Right here, this angle is when you divide a straight angle in 4 equal parts. Right here, 1, 2, 3, and 4. So pi divided by 4 is, well, pi over 4. And then 2 pi over 4, that's pi over 2. 3 pi over 4, right here. 4 pi over 4, well, that's just pi, right? 5 pi over 4, if you add another pi over 4, you'll be right here. 5 pi over 4. 6 pi over 4, that's the same as 3 pi over 2. You can check it out. 7 pi over 4, 7 pi over 4. Here are all the common angles in radian around the circle. I hope this lesson was clear. Thank you for watching.